So today we'll make a start by looking at descriptive statistics. This is an area of statistics that deals with collecting data and describing the data that's been collected. Specifically today we'll be looking at populations and samples. What are they? What are the differences between them? And we'll delve into the advantages and disadvantages of both population and a sample. We'll have some definitions and such, so be ready to pause, take some notes, and maybe even some screenshots if you're actually watching on a phone. These concepts are going to be new, and it's important that you really get these concepts, so make good use of the pause button, rewind if you need to, maybe even come back and watch this video through again later on as a bit of revision, and since you will have a better understanding of what we're going through, I'm sure everything will slot into place for you. Let's start with a population. A population in statistics means all of the individuals or the items that we're interested in for a particular investigation. It's going to be the whole set of items or individuals that are of interest. Now, this is not the same definition as you might get in geography or biology, where the population is about all of the animals or all of the people living within a particular place. Here we're expanding it. This could be all the electric cars in the UK, or all of the iPhones that have been produced by a particular factory. It could be the height of year 10 students in a particular school. It could be the number of wild worms living in a park. It could be the salary of university undergraduates living in southwest London. Just a whole set of items or individuals that we're interested in for our investigation. If we go ahead and gather data or take measurements on every member of the population, then we are conducting what we call a census. But it's not always possible to get information, to gather data, to take measurements from the entire population, from every member of the population. Now, this may be because we don't actually have access to all the members of the population. If we were measuring the lengths of worms in the park, we can't guarantee that we've taken every single worm in the park and measured it. It may be because of other constraints. It might be down to time or to cost. It'll be very difficult to try and get all of the members of the population interviewed or measured. In these cases, where we can't access the entire population, we need to take a sample. Now, there's a number of different ways in which we can take a sample, and I do talk about them further in videos in this playlist. But the idea is that we take a manageable subset of the population's members, and we use that to gather our data. And we try to take measurements from them, and we're really wanting the sample to represent the population well enough that we have a good indicator of what might be happening in the population. If we measure or interview just a few people, hopefully that will represent the views of the entire population. Now, the sampling technique that we use plays a huge role in whether or not we do generate that representative sample. And once again, we'll go through different sampling techniques and their strengths, merits, and disadvantages later on in the playlist. Now, another reason why we might choose to take a sample rather than a census is whether or not we're testing to destruction. Now, this means that when we're testing an item, it cannot be used again after it's been tested. So, if a company wanted to conduct a stress test on a mobile phone to see how much tension it can withstand before it snaps in half, we can't do that to every single mobile phone, or there'll be none left to sell. Now, this works exactly the same way if we were to test cupcakes, or if we were testing how long a battery lasts, because we've taken a bite out of every single one of those cupcakes, or we've fully depleted the batteries. In both cases, these cannot be sold after we've tested them, and we decided to test them all, so this just isn't viable. Now, it's important to remember that regardless which of the sampling techniques we use, each and every time that we collect a sample, it's likely, in fact very likely, that we'll have a different sample to what we would have got previously, or a different sample to what somebody else may choose as they collect theirs. Different samples mean that there's actually a different combination of the population members that are being selected to be interviewed, measured, tested, whatever it may be. The accuracy or the validity and confidence that you can have in a sample that you take will depend on two things. And firstly, it's going to be the sample size. The larger the sample, the more members of the population that are involved in the data that we're going to then go ahead and work with. And secondly, bias. Now that's whether you've chosen a sampling technique that's free from bias or one that is at risk of bias. Okay, well, let's just quickly catch up on some terminology here. We're going to refer to sampling units. Now, each individual member of the population is known as a sampling unit. Each individual person or item is a sampling unit. Now, the sampling units can often be arranged or given unique numbers or unique names, and we can actually list them. And if we have a list of all of the sampling units, we refer to that as a sampling frame. Now, that list might actually just be a register. It might be a database. It might just be a list of any form. If we can identify every single member of the population, every single sampling unit on a list, we refer to that as the sampling frame. Circling back to populations and samples, we're going to try and look at some of the advantages and disadvantages of each. Now, taking a census, which is to use, measure, interview every single member of the population, every single sampling unit, is the ideal situation because we have completely accurate results. We were trying to find out something about the population, and we've used every member of the population to come to our conclusion. This is completely accurate. But there are some drawbacks and difficulties in trying to take a census. Let's go through some of the disadvantages. Now, one of the main disadvantages of trying to take a census is that it can be time consuming and actually expensive depending on the scale of your census, depending on the size of the population. How many individuals are there to assess, to interview, to measure? Secondly, we can't use a census if we're testing to destruction. I mentioned this before. If the item is not going to be able to be useful afterwards, we can't go ahead and test every single item because we're basically destroying every single item. And lastly, we can have heaps and heaps of data to work with and process afterwards, depending once again on the scale, on the size of our population. Alternatively, we can use a sample, and the advantages of using a sample match up with the disadvantages of a census. So, the advantage is that it will be cheaper. An advantage is that it will be quicker. An advantage is that there will be less data that we have to process. The disadvantages, however, of a sample, when we're only choosing a subset of the population to work with, when we're only trying to get information from a few sampling units, is that our data may not actually be as accurate as we want it to be. Some samples and some sampling techniques may actually be prone to bias. On top of that, depending on the size of the sample, we might not get a sample that is truly representative of the population, especially if there's subgroups that are quite small in the population. They may not really be picked up in the sample or represented well in the sample. But if your sample is large enough and you've actually chosen a good sampling technique that's free from bias, then you're likely to get good indicators of the population characteristics from your sample. As in, if you calculated a sample mean, it's likely to be close to the population mean. We do, however, have to be cautious, and exam questions may ask you about this. We have to be cautious about assuming that a sample statistic is immediately the population statistic. We sometimes have to critique the sampling technique that we've picked or that we've chosen, and we need to just make mention of the fact that there may be a chance that this does not represent the population characteristic. Okay, so let's just jump into an example here. We've been given a scenario where a supermarket wants to test their deliveries of avocados to see just how ripe each avocado is. And their way of testing is to cut it in half. We've been asked to suggest the reason why the supermarket should not test all of the avocados in their delivery. Well, basically, if they're testing all of their avocados, that means they're taking a census. And since they're cutting each avocado in half, if they were actually to take a census of all of their avocados, they're going to cut them all in half. This is testing to destruction. So it's not going to be sensible to use a census because there won't be any avocados left for them to sell. Unless somebody wants to buy an avocado that's already been cut in half, and I'm not sure how many people are fans of that. In part B of the question, we're told that the supermarket tests a sample of 5, so sample size 5 avocados, and finds that 4 of them are ripe. They estimate that percent of the avocados in the delivery are ripe. So we need to discuss and suggest one way that the supermarket could improve their estimate. And really, a sample size of 5 is quite small, especially if they're getting hundreds and hundreds of avocados every day. So I would immediately suggest that they take a larger sample size, like possibly 20, even 10 avocados would be better off than just testing 5 of them. Because generally, the larger your sample, the more confident you can be about the results or the predictions that you might be making. In fact, if you make your sample as large as it possibly can be, it turns into a census. And we know that a census is wholly representative. So yeah, increase the sample size. That would be the recommendation. Okay, and we're just about finished. But before you move on to some practice questions, let's take a quick look at the specification and exactly what it is that students are expected to be able to show. Exactly what the examiners are anticipating you will be confident on. While you read through that, I want to quickly remind you that it will be sensible for you to come back and watch this video at a later date, maybe come back in 2 or 3 weeks or before an assessment. And as you watch through the second time round, because you've done your practice, a lot of what you go through here should resonate with you much more. And you have a chance to really embed your understanding of the difficult concepts, the ones that have been flagged up as A-star.